All right, guys, we're talking all about special angle pairs and their measures today. So I have on my board a little figure here where I have these three lines, G, H, and I, all kind of drawn up, and they intersect to form these angles 1 through 8. All right, so a transversal on my diagram would be line G. Remember, a transversal is a line that cuts through at least two other coplanar lines on the same plane here being my whiteboard. All right, so transversal, that example, I'm just going to say line G. All right, a corresponding pair of angles. Corresponding, member, is just, they're in the same position. So for example, if I have angle 2, right, this is in, if I look at this kind of intersection of these two lines, the angle 2 is in the top right, okay? So in my other intersection, the top right one would be angle 6. So I can say angle 2 and angle 6 are corresponding angles. They're in the same position. If you wanted the same position for like 7, 7's in the bottom left, and this one would be angle 3. So 3 and 7 could also work as an example there. Alternate interior angles. Well, remember this line G, it's the transversal of H and J. So my two other lines, I either am going to be on the outside or the inside for all of my angles. So here I want the interior, so I'm going to work with these four. And then alternate just means on opposite sides of the transversal. So for example, 3 is on the opposite side as 6. They're both on the inside, so those would be a pair that would work as an example for alternate interior angles. Angle 3 and angle 6. Okay, the other ones, of course, would be 4 and 5, opposite sides, or alternate sides, if you will. Alternate exterior angles, same idea, but this time we're on the exterior of our two lines, right? If these are the two lines, on the outside of those, we're going to have maybe 1 and 8, or 2 and 7. Those are on alternate sides of my transversal on the exterior of those two lines. So angle 1, and angle 8, and angle 8. And then of course consecutive interior, again interior back on the inside, consecutive just means it's on the same side. So 4 is on the same side as 6, 4 and 6 would be consecutive interior angles. All right, I shifted my diagram just a little bit because once we make these two lines parallel to each other, I use the little triangles to show that these are parallel, then what happens is some interesting things, all right? So we still have our transversal G, and when it cuts through these two lines, H and I, now the corresponding angles, for example, 2 and 6, these are going to actually be congruent, okay? And then do you remember your vertical angles? Vertical angles are the ones that cross from each other when you have an X type of shape. So here this makes an X, right? Those are also going to be congruent. So I can also put the loops on there to show that they are congruent, okay? And likewise, we have other ones that are congruent. For example, alternate interior angles, 3 and 6. Well, I already used those, but remember 4 and 5 was another example. 4 and 5 here are also going to be congruent, like this. I'll use 2 loops there. Then they also have vertical angles. So 8 is congruent to 5, 4 is congruent to 1. Okay, so we have these kind of sets of congruent angles once these two lines are parallel being cut by its transversal. All right, so I can go ahead and erase my ands and replace those with congruents on most of these. All right, I'll do that here. Okay, and then the only one that I didn't do it on is the consecutive interior. Because if you look at those, if I look at 4 and 6, those are not congruent based off of the loops that I drew, okay? Instead, consecutive interior is going to have its own special rule. This angle 4 plus angle 6, if I add those together, that's actually going to equal 180 degrees. All right, so most of these are going to be congruent to each other, but that one happens to be equal to 180 when you add them up.